good morning students. I am Vaishakhi Shah from LJ Institute of Engineering and Technology. In our subject fluid mechanics and hydraulics, we studied, now we are studying the module which is called open channel flow. And in last lecture of this subject, we discussed most economical section, rectangular section, most economical rectangular section for the channel. Now in today's lecture, we will discuss most economical trapezoidal channel. Okay. So as you can see in this diagram, here is your trapezoidal channel. Trapezoidal A, B, C and D. A, B, C and D trapezoidal. Okay. Now depth of this channel is D. As you can see in this diagram, this depth of your channel is D and bottom width of this channel is B. Bottom of this channel is B and depth of your channel is D. Okay. You also can see in that diagram here base width which is B, now height or depth is D, and now in a trapezoidal channel this is your side slope here. In a side slope, this is your side slope, and in a side slope this angle is your theta. Angle makes with horizontal is theta. Okay. There is a one vertical to n horizontal. So one vertical to n horizontal. So your this distance become n into d. This becomes n into d. This distance becomes n into d. Clear? Okay. So if you are dividing this trapezoidal channel into parts, then there are two triangles and one rectangle. As you can see that there are two sloping sides, which makes two triangles. Two sloping sides makes two triangle, and the center part of this trapezoidal becomes rectangle. We will use this fundamental in our derivation. So we divide trapezoidal into three parts: two sides triangle and center part that is rectangular. Okay, clear? So here B is the width of the channel, D is the depth of the channel, and theta, that is the angle made by sides with the horizontal. Okay. Now remember this figure clearly. We will use this diagram in our derivation, in our remaining theory. Okay. Any doubts? Okay. So moving further to our derivation, as you can see this is your diagram for trapezoidal channel. B width, D depth, side slope which is where one vertical to n horizontal. So this distance become n into d. Okay. So now if we have to find out area of the flow, in this trapezoidal channel, then here area, what I said, we divide this trapezoidal into three parts: two triangle and what? Rectangle. So now we are finding out area for three different sections. First, what is the area of this center part where there is a rectangle? So area of rectangle is B into D. B which is your width and D which is your depth. So first we are taking area, that is B into D, width into depth, that is area of a rectangle part. Clear? Now there are two triangles, both the side there are two sloping sides. So there are two triangles. So we are taking area. What is the area of triangle? Half base into height, and multiply that with 2 because there are two triangles. So equation of area for triangle, that is 2 times 2 into half ND, because what is base width of this triangle? What is base? ND, and height is D. So half ND into D, that is area of the triangle, half base into height. Okay. So our area, equation for area, that is D into B plus ND, D into B plus ND, that is your equation number 1. Okay, we found area of this trapezoidal section. Okay, so now making A by D as your subject, by rearranging this equation you get A by D equals to B plus ND. A by D equals to B plus ND. So B as your subject, you get B equals to A upon D minus ND, where B is a base width. So equation for B, that is B equals to A upon D minus ND. Okay. So now for this is your equation number 2. Now next step, again this is your diagram of trapezoidal section. Now we have to find out wetted perimeter. We found A. Now we will find out P. Wetted perimeter, as you can see in this diagram, if we have to find out wetted perimeter, wetted area, wetted surface, then P equals to, see in this diagram, first AB, A into B, that triangular part, plus BC, that base part, and third CD, again the triangular part. So that gives you wetted perimeter AB, BC and CD. So total wetted perimeter P equals to AB plus BC plus CD. Now you can write down AB plus CD equals to 2 times into CD, because both are the equal lengths. So you can write down P equals to BC plus 2C into D plus twice CD. Okay. Now P equals to, what is BC here? From the diagram you can see that BC equals to B, base width. Okay. And 2 times CD, by applying Pythagoras equation you get CD equals to under root CE square plus DE square. If you are applying Pythagoras rule, then you get C into D. CD equals to CD, your inclined side. CD equals to CE square plus DE square. Okay. So here what is CE? From the diagram you can see that CE equals to N into D. Okay. And DE vertical side, which is D. So equation become P equals to B plus 2 under root N square into D square plus D square, because CE equals to ND and DE equals to D. Clear? Now rearranging this equation you get B plus 2 into D under root N square plus 1. This equation is for perimeter of triangular section, wetted perimeter. Okay. This is your equation number 3. Now placing the value of B from equation number 2. Now this was your equation number 2, where B equals to A by D minus ND. Placing the value of B in equation number 3 here, this equation, placing B in this equation. So you get P equals to A upon D minus ND plus, replacing B with A upon D minus ND plus 2D under root N square plus 1. So this equation is for perimeter, wetted perimeter in trapezoidal section. Okay. Now moving further, again this is your diagram for trapezoidal section. For most economical section, what was the condition for most economical section? Yes, for most economical section, perimeter, wetted perimeter should be minimum. We also discussed this in our most economical rectangular section also. Here we are finding out conditions for most economical trapezoidal section. Okay. So for most economical section, perimeter should be minimum. So applying that condition, dP by dd equals to 0. Differentiation of perimeter with respect to depth. So dP by dd equals to 0. Now we have the equation of perimeter. P equals to A upon D minus ND plus 2D under root n square plus 1. So putting this equation of P in above equation dP by dd equals to 0, you get this equation that d by dd into A by D minus ND plus 2D under root n square plus 1 equals to 0, placing the value of equation of P here. Okay. So by differentiating you get minus A upon D square minus n plus 2 under root n square plus 1 equals to 0. You get this term by differentiating with respect to D. Okay. So you get, rearranging the equation, you get A upon D square plus n equals to 2 under root n square plus 1. Clear? Okay. So now substitute value of A from equation number 1. What was the equation number 1? A equals to D into B plus ND. Clear? Now placing value from equation 1, you get D into B plus ND divided by D square plus n equals to 2 under root n square plus 1. Here we are placing the equation of A. Okay. So by rearranging the terms you get that B plus ND divided by D plus n equals to 2 under root n square plus 1. So here B plus ND plus ND taking LCM divided by D equals to B plus 2ND divided by D equals to 2 under root n square plus 1. Clear? Okay. So final equation become B plus 2ND divided by 2. B plus 2ND divided by 2 equals to D into under root n square plus 1. Now, so half of top width equals to one of the sloping sides. Here in this condition, this is a condition for most economical trapezoidal section, and in this condition B is a width of the channel, D that is a depth of the channel, N that is a side slope of the channel. Okay. So this you have to remember this condition for solving examples as well, that B plus 2 and D divided by 2 equals to D into under root n square plus 1. Okay. Now another part of this derivation where we know that A equals to D into B plus ND. We know all the equations now, and P that is B plus B into plus 2ND. So final equation for P was B 2 into B plus ND. Now we have to find out hydraulic mean depth. What is the equation for hydraulic mean depth? M equals to A upon P. We have the equations for area here and perimeter also. So placing both the equation in M. So M equals to A upon P. Area that is D into B plus ND, and equation for perimeter P that is 2 into B plus ND. So you get that M equals to D by 2. Now what is M here? Hydraulic mean depth. So for most economical trapezoidal section, hydraulic mean depth M should be equals to D by 2, and here D that is depth of the channel, depth of the trapezoidal section. Okay. So these two are the condition for most economical trapezoidal sections. Clear? So in today's lecture we discussed conditions for most economical trapezoidal section. Now in further lecture we will solve some examples based on trapezoidal section and rectangular section as well. Okay. Goodbye. Thank you.